Alright, so let's go ahead and take a look at homework 2.5, or the homework for sections 2.5 and 2.6. First one is 2.5, number 12, which is to evaluate the limit as x goes to infinity of 3 plus 2x plus 4x squared all over x squared. On a problem like this actually could be done a number of different ways. I'm going to start off by just breaking this up into different pieces. So to me, this one kind of screams to do that. So I'm going to say this would actually be equal to the limit as x goes to infinity of 3 over x squared, just the first part, 3 over x squared, plus the limit as x goes to infinity of 2x over x squared, plus the limit as x goes to infinity of 4x squared over x squared. And it's worth noting that some of these might be able to be reduced a little bit, but before I do that, I actually think, well, I'll go ahead and rewrite it here. Let's limit as x goes to infinity. This one stays the same, 3 over x squared, plus the limit as x goes to infinity. But now we have an x in the bottom, we have an x in the top, so this could just become 2 over x. We get rid of the x up here, we get rid of one of the x's, so this x goes away, one of these goes away, so it just becomes 2 over x, plus the limit as x goes to infinity. And now we have x squared over x squared, which is just 1 of 4. So that's kind of a trivial scenario. But let's go ahead and evaluate this now. So what we would do is we'd plug infinity in for each one of these. Well, if I can plug infinity into the denominator, this whole thing goes to 0. Plus, I'm going to put infinity over in the denominator here, 2 over a really, really big number. That also goes to 0. Plus, the limit as x goes to infinity of a constant 4 is 4. So in this case, 2.5, number 12, your answer is going to be 4. Going on to the next one here, this would be 2.5, number 22. Take a look in my book here. Alright, so this isn't quite as trivial of a case. We've got a bigger number here, and what they want us to do is a little more work here too. They want us to determine the limit. Oh, excuse me. Evaluate and give any asymptotes. So on a problem like this, we talked about a kind of a solid approach to doing something like this is dividing the entire problem by the highest exponent. Let me show you what that means here again. So what we're going to do is we're going to take and do the limit as x goes to infinity, and it's really plus or minus infinity here, of, let's start out in the bottom. We're looking at the denominator for the highest exponent, so 8x squared. So x squared is the highest exponent. So I'm going to do, we'll do 8x squared over x squared plus 5x over x squared. So everything divides by x squared, plus 2 over x squared. And if I do that on the bottom, I also have to do it on the top to keep the equation balanced here. 4x squared over x squared minus 7 over x squared. And this is going to be equal to the limit as x goes to plus or minus infinity. And on the top, the 4x squared over x squared just becomes 4 minus 7 over x squared. And on the bottom, we get 8 plus 5 over x plus 2 over x squared. And it makes no difference at this point what I'm talking about as far as infinity goes. If I go to plus or minus infinity, it doesn't make a difference. In this case, this number goes to 0. This number is going to go to 0. and this number is going to go to 0. So the limit is actually going to be equal to 4 over 8. And it'd be worth mentioning, well, then that goes to 1/2. So what does that mean? That means this whole function, if I was to graph it right now, it would have y equals 1/2 as a horizontal asymptote. And it might be worth us just taking a look at this one, just to graph it once and take a peek at what this thing looks like. So I'm going to go to Desmos. And I'm just going to plot the original function just the way it was written. Go to Start Graphing. And basically I'm going to say y equals 4x squared minus 7. And that's going to all divide. Let's do this so I can get it all to divide here. 4x squared minus 7. That's all going to divide by 8x squared plus 5x plus 2. And what you'll notice here is what we just talked about a minute ago on the slide here. I apparently lost my my notes here. But what we talked about was that the horizontal asymptote actually was going to go to y equals 1/2. So if we go back into the shot here, what you'll see is whether I'm going to negative infinity this direction or positive infinity this direction, you'll notice that my value, as x goes up, my value of y gets closer and closer and closer and closer to 1/2. And I can follow this thing all the way over. You can see it's just riding up near 1/2 the entire time, both in the positive infinity direction, 1/2 being right here, and in the negative 1 infinity direction. So in both cases, that became my horizontal asymptote, which is what the limit really allowed us to prove there.